did. So, like I said, from the folks who were able to finish, we're still getting about half the questions correct, which is okay. These are hard and complex and tricky. Ugh, okay? But hopefully you guys agree. That's the way it makes you feel. Okay. So hopefully this overview is beginning to kind of make sense and hopefully it's kind of beginning to stick in your mind. All right. So I think this question was just tricky because the information that we get in the first sentence is not right the information that they're asking about. So that's where, right, it gets tricky. So, drum roll. Okay, so a survey is given to 300, or sorry, a survey given to 300 runners showed that 24% would rather run barefooted than run wearing shoes. Many runners surveyed said they would rather, oh, sorry, goodness gracious, sorry. How many runners surveyed said they would rather wear running shoes? Okay, and so hopefully you caught, if you could, through my horrible reading. Okay, so I'm always finding my information here. So I have a percent, but the percent I'm given is not related to the part, right? So this percent does not represent this part. Does everyone agree or see that? Okay. And so how would we go about figuring out the other part of the group? There's kind of two ways you could go about it. That's okay. Yeah.
So would you have to find the percentage of the opposite of 24%?
So that's definitely one way you could do it, right? Take 100% minus 24%, which would tell us, right, the percentage of the other group who says, yes, I prefer to wear running shoes. So good. So that's one way we could do it. So what is that number? If 24% chose barefooted, then what percentage chose running shoes?
7 to 6.
6, right? Good. Maybe. Do you want to? Yeah, good. So we know that the part that we're interested in to answer the question is 76%. Okay. And so then we have a percent and a whole. So I take my percent times my whole to get the part. So 0.76 times 300. And so 228. So that's one way, right? If we use subtraction as our first step, right? We take our percent from 100% to find the part that we care about. Okay. Did anyone remember or do it a different way?
You do 300 times 0.24.
Mm-hmm. Good. So the other way is to basically kind of reverse the steps, which means I'm going to figure out what 24% of my whole is. So 24 times 300. And so I know that the barefoot total, people preferring barefoot total is 72.
Then minus 300.
Exactly. So then we do a subtracting step as our second step. Wow, sorry. I don't know why my twos are looking very inconsistent today. Sorry. Good. So 2 ways we get the same answer. Do you want to subtract first or do you want to subtract second? So the steps are the same. It's just what we do with them is a little bit. Okay. So good job. So 228 is the answer, and I'm thinking that a lot of people probably got 72, which would have been right the part if we were curious about how many of our 300 runners run barefoot or are liars, in my opinion. But I don't really hear very much about barefoot runners anymore, but maybe. All right. Questions, comments about the first problem? Is it feeling okay to everyone?
So
So see,
228 runners was the correct answer.
correct.
All
Because
right, because on our warm up, it says that it was incorrect. It said that the correct answer was. Oh no, you're right. You're right. I'm sorry. I looked at.
uh-oh, now Garrett's doing what Ryan does to me. Okay, no problem, Garrett. I understand. But good. I was like, I really tried hard to make sure I marked the answers because I forgot one last night. But I remembered to mark it on this one this morning. So yeah, the answer should be C or 228 for number 1. All right, like I said, hopefully this one made sense. And I would say, I think I mentioned this, this is a pretty typical style GED question that's a little bit more about logic than, so you kind of have to test all the answers, I guess is what I would say. So it says, which of the sale prices described below would save you the most money or gives the biggest discount, and not the biggest percentage off the original price discount, right? But we're saying if I take a 5% discount of $43, right, that part, how much actual money am I saving? How much money is actually getting discounted off the total? So, like I said, I was trying to figure out if I could kind of logic my way to the answer. And of course, as you see, right, as the price decreases, the amount of discount increases, but right, when you take 30% off a $12 purchase, right, you're not going to save as much money as if you get a smaller discount on a bigger purchase. Does that kind of make sense? But like I said, I that's as far as my logic brain went, and then I'm like, but these numbers are kind of close together, and my brain doesn't work very good. So, did anyone get the right answer for this one? No? Okay. All right, so, okay. So how would we go about confirming which one of these, right? So if we find the part, which is our dollar amount of discount, right? Then we would just compare those 4, and whichever is the most is our answer. Does that make sense for everyone? Did anyone do it that way? If you did it a different way, let me know. So for example, right? You did, and how did that work?
Good.
No problem. So if we have $43 and what is 5% of 43? So with the 5% discount, we're going to take off $2.15 from that one. Okay, excuse me. If we have a $36 purchase and we're taking 15% off, that means, right, that the discount we get is $5.40. Okay. So already, right, we know that A is not the right choice because the discount, right, the money I'm taking off of this choice B is greater. Which would make sense, right? Because it's quite a bit more of a discount, right? 10% more of a discount, so that's a pretty big jump, whereas this one's just going 5% and then that one goes another 10. Anyway, okay, focus. $25. Let's see if you're right, right? 20% off is only a $5 discount. So do we think we're gonna get a bigger discount if we take 30% of 12? Is that gonna be a larger value than $5.40? Probably not, right? Because that would be over almost half, right? Let's just confirm, but I agree with you, Valerie. So sometimes if you kind of get, the first three figured out and it feels like you kind of already got a pretty good candidate, you could kind of save yourself some time, but 12, so 30% of 12. And so you were correct, good. Okay, it's just a $3.60 discount. So we're saving the most, right? If we buy a pretty fairly priced item for a, pretty good discount. But of course, once again, right, the pattern that you'd want to see here is, right, the smaller the discount, right, and the smaller the amount, right, the amount you're taking off gets smaller and smaller. So how does everyone feel about this problem? Was it confusing what it was asking? Did you feel stuck or frustrated by this one? Stuck? Okay. Was it hard to understand what it was asking, or just hard to know what to do with all of the numbers, or having to know that you had to do all 4 problems kind of? And that's, like I said, one of the styles of questions they like, where it's like they kind of give you a very general question and then you have scenarios as your answers. You kind of have to match the scenario. And so it is challenging. So that's why I chose this one, because I wanted us to see it as a group. So that we could talk about it. Any other comments or thoughts about question 2? Everyone's on Zoom's hanging in there? Okay. All right, let's look at the next problem. So now we're on to our percent change, okay? The Outdoor Swimming Club offers memberships during the winter at the discounted price of $126. So here's one of my important pieces of information. The membership price increases in spring and summer to $180. So, and then it says, right, what percent below shows the discount applied for those who paid memberships in the winter, right? So we know that we need to calculate percent change. And so I know that my unknown value is going to be some percent out of 100%. Okay. And then I know that I need to set that in proportion to the amount of change. How do I figure out the amount of change between my 2 numbers? Ryan, sorry.
I know you want to work on it. I just guessed I'm not correct.
Okay. What made you guess 30%?
That says the very small increase.
Okay, and how did you figure out that there was a very small increase?
Yeah. 126.
Good, yeah, so it's really only, and so you just chose the smallest amount because it felt like the smallest increase, and I think that's okay. You might not get so lucky with your answer choices, but I think that's good logic. What we would need to do, right, to officially get the answer is to, find the amount of change by subtracting, 180 minus 26, which is 54. That sound right? Yeah. Thank you. And then What do I use as my denominator here? Which number? 180. Good. And that's because the way, and the question's worded in a little confusing way, and I actually confused myself last night in class, but you know, if this is the discounted price and it's only applied during, you know, a shorter part of the year, then we would probably say that the 180 is the original amount, right? Because we're taking the discount off the 180 to get to the 126. Okay, so this is how we would officially set up the problem. Percent out of 100 equals the amount of change between our two numbers and our whole, our original amount, our starting amount. So yeah, I think it's because it kind of introduces the discount before telling us the original price that it could come across a little confusing. But cross multiply 54 times 100 is 5,400 divided by 180. So 30. So yeah, if you guessed, fine. If you set up your proportion and solved and can confirm the guess, good. All right, any thoughts or questions about these two problems?
I did that one the same, but except for 54, I did the 126, then you got it. You got 70 out of 100, so.
Oh, okay.
Does that make sense?
Oh, okay, so you found out that 126 is 70%
Yeah.
of, yeah, so yep, that works, sorry, took me a sec. Yep, that's another way to figure it out, yeah. Cause if you find the percent from the part and the whole, and then subtract that from 100%, you'll get that
Or
discount.
if
So
you get
yeah.
126 over 180 and simplify it at 7/10. So that's
Nice.
70 and then.
Yeah. So yeah, you know that this is 70% of this, so the difference then, right, or the percent changes 100 minus 70, which is 30. Good, yep. Thank you. So yeah, couple of routes to get to the right answer. Hopefully everyone's kind of seeing the pattern, seeing how to organize the information. I think sometimes these problems are challenging because once you do some calculating, knowing what you kind of have, what you've discovered or what you've calculated, sometimes knowing exactly what that means or is can be challenging for sure. All right, last question. This one had quite a few steps to it and a lot of information. A sweater originally priced at $54.99 is put on sale for 20% off. Okay, so we get two important pieces of information in the first sentence. Each sweater costs the store $20 to purchase from the manufacturer, right? So this is the store's cost. This is the store's price, but they did have to reduce the price a little bit. Okay. If 200 sweaters sold at the sale price, how much profit, and we're going to round to the nearest $100, did the store make? So lots of information, lots of numbers and stuff going on here, lots of 2s and 0s. What do we need to do to get started on figuring out this question or this problem?
The sweater.
The price of the sweater, what?
The 20% discount.
Okay, so we need to find the sale price of the sweater. Good, I agree. How are we gonna do that?
54.99 times 0.20.
Good. So we can either apply the discount and then subtract it from the original, or, right, we can say if it's 20% off, then it's now, right, 80%. I'm paying 80% of the original price. Once again, depends on which side you want to subtract from, but good. So let me write this down. So step 1. We have kind of 2 ways to do this. We can say, what is 20% of our price? So whoopsie doodles. I really like hitting that 0 instead of the decimal. Times 20%. So we're gonna take off about, right, $11. I'm just gonna round that up. That's basically $11, right? So we're gonna say that's about $11 discount. So if I take, whoop, $54.99 and apply my discount, that means, right, that the sweater sale price is $43.99. Okay, so now we know how much people are paying, right, for the sweater on sale. What should be our next step? Or am I done? Doesn't look like I'm done if I have like thousands down here.
What I did next was
Uh-huh.
round up to $44 times 200.
Okay. All right, did you factored in this idea later?
Yeah.
Okay. All right.
This 200 is how many sweaters were sold, so they're asking if 200 sweaters sold at the sale price.
Mm-hmm.
So I did the 200 times 44, and then I did the 200 times 20, and I
Mhm.
would off 2 deducted, and that's how I got my answer.
Very nice. Hopefully you guys could hear, I don't know, but yeah, so you could then, once you find the sweater sale price, then figure out, right, the total amount of sales, right? And then calculate the cost to the store based on the sales and then subtract those two. For me, I'm just gonna kind of follow the order of the sentences, but your directions are good. But I know the sale price of the sweater now. And since I know the kind of the store's cost, right, to get the sweater and then, right, mark it up to sell it. So I could, right, take my, oops, sorry. Like I said, I'm just kind of following the order, but the order you did on how works just fine too. So for me, I'm like, okay, and I like that you just rounded that up to 44, that makes sense. So if the store pays $20, right, then I would need to subtract that. So I know that the store's profit, right, that they make on each sweater sale is about $22, right? Because 44 minus 20 is 22, right? So we had to figure out what this sweater costs on sale. Then you could, right, subtract. And so now this 22 means, right, this is the store's profit on one sweater. Okay. And then we could do the times 200 and get the same answer, which is 48. Um,
Oh.
Maybe you only did. So that maybe you got the discount, but then you treated that like the profit, maybe? Hmm. So yeah, no, your steps are fine. Like I said, I'm just kind of following this a little bit. So if I make $22, right? If the store makes $22 on every sale price sweater and I sold 200, right? So 22. I don't know what's wrong with my twos today, guys. I'm so sorry. 22 times 200 is 48. Okay. So sometimes there's a lot of steps. Hopefully, as long as you know, don't panic, trust yourself, read carefully, find the key details, and then you don't necessarily have to map out, right, the exact steps that I followed because, right, we know that you can kind of do the steps in other order.
Julie,
Yes, Kenan.
put 22 times 200, I came up to 4,400.
Yeah, I was gonna say that.
Oh, snap. I'm like, uh-oh, 40, oh, wait, 44 minus. Oh, so did I mess up the answer? Now I'm like, oh, ah. Let me look, Kenneth, thank you. Well, how did I get that? I swear I got it last night. Did I round? No? Okay, so I'm sorry, I guess I messed up the answer. Pretty sure it's supposed to be 4,400. I'd have to go to my office to find the book, and so I'm sorry about that, darn it. Well, I guess in that case, just choose the number that's closest, darn it. Now I'm confused. Um, Sorry, just thinking for a sec. Oh, can tell it's the end of the week, right? How's that for an excuse? Okay. Okay. Let me get you guys working on something. I'll go check my book because like I said, it's definitely probably a me error, but let me see if I can find it. So, does anyone need to write down any of these notes before we wrap up our warm up and go to our book?
Yes.
Okay, I'll give you a sec. All right, sorry guys, got distracted. All right, Angelica, you good? You got your notes down? Okay,
Yeah, I'm good. Thank you.
of course, no problem. Yeah, I'm not sure how I got 24 last time or if I got 24. We'll have to look at that, Mel, because like I said, I'm very quick to blame myself because not my forte, but yeah, we'll see. I'll check and see if I just copied it down wrong, which I think is right. But okay, let's hop into our lesson. So we've basically kind of reached the end of this unit. I know we have 2 more units to get through, and I'm trying to decide if we should start a new unit next week or just review the first 2 units. And then and this is why I'm showing the calendar up here. So next week is the last week of our first fall. Sorry. Okay, one more time. Next week will be our last week of fall 1 quarter classes. So we'll have regular classes just like we have been next week. And then the week of October 14th through the 18th, or actually 14th through the 17th, we will not have class. We'll have a break, a 1-week break from classes, just so that, yeah, Ashley, I was kind of feeling like review is probably a better thing since we'll probably have new folks joining us as well, and I don't want them to quite get as abrupt of a start. So yeah, we can definitely figure that out next week. So yeah, so we won't have these classes on the week of October 14th through the 18th, but then starting October 21st, classes will basically resume. And I don't have any reason sorry. What I'm trying to say is I don't think the schedule is going to change when we come back from our break. And so during this break week, it's a really good time to take your civics test. If you haven't done that already, you can, because you have to pass it if you want your diploma in Arizona. So I guess if you want to pass the 4 GED test, move to another state, establish residency in that state, and then transfer your GED scores over, you could do that to get your GED. More questions, or is this just, okay, sorry, just checking. Okay. So, yeah, so I will be taking a couple days off in the break week, but I'll be on campus on Thursday and Friday that week if you need to meet with me for coaching. I've been contacting some of you guys who are ready to progress test, and so break weeks are another good time to take a progress test if you've gotten to 40 hours. And so I'll be reminding you guys about this next week as well, and all those things, but just have that kind of on your radar coming up down the pipes. Okay. All right. Okay. So let's hop into our packet. Just to remind everyone, maybe, oh, I didn't save it on there. Okay, so sorry, darn it. Sorry. Okay, page 39, right, is one of our really key pages in this unit. that lays out, right, our foundation for these percent problems. So please, right, make sure that, you have this page marked and that you've been able to kind of write out our foundational formulas and that you're feeling good about the information presented here, okay? And then from there, we're going to jump to page 46. And page 46, right, is where we begin to see those multi-step problems where we'll have to apply Yes, Mel, I will do my best to follow up on that with you later today. And thank you for being patient. I can definitely get that figured out. This is page 55, 46. Sorry about that, Diane. Page 46. It says 46 down here in the bottom middle, or it says 15 on the far right side there. But we're on page 46, okay? And so as we mentioned, right, the first kind of multi-step percent problems that we deal with are either, right, using a percent and a whole to calculate a percent increase, which will give us a new amount, or, right, like we've been doing quite a bit, this rate decrease, right? Taking a discount, reducing, right, costs by a certain percent. So the key here, right, is that there's a percent and there's some kind of whole that we're either, right, going to increase from or decrease from depending on the situation. And so our first step is to find the part, which is either going to be the amount of increase or the amount of decrease that we're going to apply to that original amount, the whole, okay? So hopefully everyone's feeling mostly good about these, and we've kind of seen as well that, especially with the decrease, you can, yes, Ashley, I put it in the mail. I think it got picked up yesterday, so hopefully you'll have it by the end of this week. If not, hopefully on Monday. But I did get it mailed. All right. So hopefully everyone's feeling good about these first two scenarios. And I think you guys are doing a good job of getting the steps down. And so, like I said, if you can recognize what they're giving you and what they're asking you, hopefully you can answer the question. So of course, two of our scenarios that relate is percent increase often occurs, right, in this kind of retail context, right, where we're taking the store's cost, marking up the cost by a certain percentage, and therefore, right, we're doing a rate increase so that we know, right, the store's price, what they're charging the customers, okay? And then we've talked quite a bit about discounts. Hopefully, ocular deals with your eye, right? Yeah. Did it sound like I said ocular? Oh, okay. That's a fun word though, isn't it? Okay. So, and then our final important situation is that third problem that we warmed up on. And this is, right, when we need to figure out the percent of change based on, right, two numbers. And either it's increased or decreased. The direction of the percent of change isn't super important in the calculating of it, okay? So we need to take our original number, subtract it from the number with the change, right? And then use our proportion to figure that out. So hopefully everyone's feeling good. And so just to look at the example, whoa, hello. when it goes from 200 to 300% magnification, that's big. So here the change in Jane's profit from 1 month to the next was $500. So that goes on the top of our proportion. This is page 49, Diane, just to help you if you're. And then our original amount was 2,000, cross multiply and divide, and we get 25. So that tells us, right, that there was a 25% increase in profits. Okay? So that's how we figure out the percent of change. Hopefully that's feeling good for everyone. Okay? And then this one other kind of funky scenario that's a little bit hard to conceptualize is that if we're talking about a percent change, sometimes our percent can be greater than 100%. And that's because, right, our starting amount has, right, more than doubled, right? So that our amount of change is greater than what we started out with. And so if John began with 5 and now he has 20, that means the amount of change was 15 and the original starting amount was 5. And when we cross multiply and divide, we get 300, which means that the workforce has increased 300%. Okay, 4 times increase. Okay, so if your whole doubles, right, we go from 5 to 10, that's 100% increase because we doubled our whole. Okay, is that feeling all right for everyone? So if it's percent change, but if it's just percent, then it's generally going to be, between 1 and 99. Okay. Comments, thoughts, confusions? Okay. All right. So lots of practice problems, but I want us to move to page 52. Good. And go ahead and just work on problems 1, 2, and 3 at the top of page 52, please. And let me know when you're ready to talk about these problems. And if you're on Zoom, if you could share your answers in the chat, I would appreciate it just so we can see what you're thinking. But I'm going to let you guys work on that. I'm going to go grab my book and check on that stupid problem.
Hmm.
Yeah, it was supposed to be 48, and I just suck. I can't even copy out of books. Is everyone doing working? Yeah, number 3 is a little tricky, Ashley. So yeah, we'll definitely talk about that if you can hang on. And hopefully for number 2, right, you need to choose 2 of the 4 choices, not just one. Okay. Does anyone want or need more time on these 3 problems? It's okay if you do. One more minute or so, you think, or not getting any? All right, let's go ahead and see how we did. So number 1 is another style of question that the GED favors. And so these questions, thanks, Kenneth. So these questions, right, ask for what we call an expression rather than, the final answer. What is an expression? Does anyone remember, Ryan?
The way you will write it.
The way you will write it, the problem. Good. Yeah. So an expression is what we do when we set up the problem and plug in the numbers. So exactly. So basically The expression is what we're planning to type into our calculator, right? And of course, they can get more complicated, they can get less complicated. So Kenneth, you chose D for number 1. What do you guys think? Is D the answer? A, okay. B, C, okay, we can D, okay. All right, Valerie, why do you like A and not D?
D.
I chose A as well.
Okay. Mm-hmm. Good. So once again, kind of like good, Mel and Z, you guys are getting it. So if we need it, if our whole was 133, then expression D would work. But if you read the question carefully, right, we know that we have our percent here, but what is the 133? Right, it's actually the part. And the question's asking how many people attended in all, right?
Which it's asking for the whole, right?
Yep,
Okay.
correct. And so good. So because we have a percent and a part, we need to find the whole. And so the correct, right, combination is to take the part divided by the percent, and that will give us the whole. Okay. So answer D is pretty attractive, but you have to recognize that 133 is the part, it's not the whole. Okay. Sound good?
Mm-hmm.
Okay. So like I said, you know, that first step in what makes these problems challenging is, right, well, sorry guys, I clearly have to cut myself off. It's a good thing I'm out of coffee. Is finding those parts, and what parts do I have? What part is missing? Okay. All right. For number 2, Kenneth says that B and C are the same value as 40%. Do you guys agree? Okay. But there's 2.
Oh,
I know. But Valerie says yes. Very good job, Kenneth and Valerie. Okay, so remember, I think it's like way back on page 36, we had that chart, right, where we looked at the equivalence between the percent
It's
form.
page 35.
35, thank you, Ken. Thank you, Kenny, for clarifying for me. I appreciate it. I clearly need a lot of help. Good, thank you. Yeah, so on page 35, if you go back to there, you know, look at that box, because it's also going to help us on question 3. Okay, but just so everyone's hopefully remembering that very first lesson on percents, where we really focused on the fact that percents have an equivalent decimal and fraction form, and we use it to represent those values that are less than 1, greater than 0, and depending on what we're doing with that small value, right, what way is the best way to represent it. Okay. Did anyone get an answer for number 3, or do you guys need a little bit more time, or are you like 4.4 workers? Okay. Okay, so let's read the question. So, Fortrell Lumber Company, thank you, Z. We'll see if that's correct. Fortrell Lumber Company announced that it would rehire 66 2/3%, right? So here's my percent of the 191 workers it laid off last month. And then the question, how many workers are going to be rehired? So is the 291 a part or a whole in this problem? A whole, good. Right? Because that's the whole number of employees laid off. And then, right, if they're gonna rehire 66 and 2/3% of them, then the amount to be rehired should be the part. So we definitely know that our answer needs to be a number smaller than 291, but it should also be a whole number. Because usually we count people in whole numbers, right? Hopefully. Okay. 66.75. That's okay. So does anyone remember how we should deal with this really annoying percent that has a fraction in it? Does anyone remember? I wish. No, we need to work with this.
So I thought it was like, don't you have to times like 3 times 66 and then whatever that is, you have to add that to 2?
Well, if we wanted to turn the percentage into an improper fraction, that's what you would do.
Okay.
And so we know, right, that we're looking for the part, we have a percent and a whole, but our percent is kind of, right, it's kind of ugly looking. And so rather than ignore it, is there another form, a fraction or a decimal form of this percent that would be easier to work with? 2/3, is that what you're saying, Quentin? You're muted, but I saw your sign language.
Would it be like 0.3?
No, but that's a good guess. You're halfway there. And so let's go back. Or not divide.
Yeah, see, this is where I missed out.
That's okay. That's okay. Good. And so, if we look at our chart, and this is back on page 35, like Kenneth told us. So, right, 66.5%, and I feel bad I didn't fill this in on here. I think that's because I was using a different document, right? And so when we look at thirds, 1/3 and 2/3, right, they're really annoying as percents and decimals because as decimals, they repeat. And as fraction or as percents, they have this mixed number look to them. So for example, if I take 1/3, 1 divided by 3, right? I get this really annoying answer, right? 0.3333333333333, and it's just gonna go on forever. Okay. Same thing happens with 2/3. I think it's 6s though. Is it? Yeah. And they eventually kind of cut it off, but truly it does once again just repeat. Okay. And so when you see 66 and 2/3%, right, we're gonna say, sorry, right? But then as a fraction, it's just 2/3. So when we need to take 1/3%, 1/3 or 2/3%, which is once again, like here you get, right, 33 and 1/3%. But as a fraction, it's just 1/3. Okay. And so when you have this percent, which is basically taking 2/3 of your whole, working with the fraction form, and I think that's what was that what you were saying, Valerie, you did? Yeah, good. So what we want to do, sorry, I'm going to jump back. Well, maybe. Like, which page are we on again? Oh, down, sorry. Okay, here we go. Sorry. So we want to deal with that percent as a fraction, right?
Yeah.
So if we treat 66 2/3% as 2/3, that should make it easier, right? So I do my whole, or sorry, my whole times my percent, which I'm going to treat as 2/3, it's equivalent. And then if you have your GED calculator, right, you can multiply numbers by fractions. I don't think I can do that on this calculator. Let me see. No. Oh, that's good. I didn't know there was a date calculator on here. Anyway, I can't do it on my computer's calculator, but good. So you got about 194. Okay.
Yeah,
So
194 on the calculator.
okay, cool. So 291 times the fraction, 2/3. And yeah, good. Good job, Mel. Good job, Z and Ken. Very nice. So we get 194. So they're rehiring 194 of their workers back. So that one was tricky. Okay. And so hopefully you can remember among all of the millions of things that I'm asking you to remember. Just make sure that if you are dealing with thirds, then it's really helpful to use that equivalent fraction form, okay? I mean, once again, you could use like 0.666 or Mel used 66.67, and that generally would work unless you need to be really precise. And that's why the fraction would give you the most precise answer, because the decimal form is this like ugly repeating thing. But the way you did it was perfectly fine.
So whenever we get any problem like this, they get 66, and then the fraction over here, we should always multiply it by the fraction and ignore the whole number.
No, what we're saying here
I
is
hear you did the
Mhm.
291 times 2/3, and that's how you got the answer.
Mhm.
So then
Because
treat it as in two numbers then in a way, two different.
well, so all of our percents have an equivalent decimal form and equivalent fraction form. So 66 2/3% is equivalent to the fraction 2/3. Okay, so these values are equal to each other.
The 66 and the 2/3.
It has to have 66 2/3% to be exactly 2/3. So it's like, this is the percent version, this mixed number, and this is the fraction version, which is like, hopefully you would agree, much simpler to work with. And so that's why, once again, on page 35, when we think about our most common, right? Wait, whoops, sorry. Darn it.
I have a question, Julie.
Just one sec, Ken. Go ahead.
Yeah, does that work for all mixed numbers, or does this only work for the 66?
Yeah, good.
Fraction?
Yeah, so the only time you're probably going to see that mixed number style percent is when you're dealing with thirds, either 1/3 or 2/3. Because when we get to 3/3, right, we have a whole, we have 100%. And so thirds kind of work on that 33, 63, 99 kind of, right, continuum, getting closer to it. And so it's all these little extra decimal places that bump it up from 99.999 to 100. And so, yeah, so it only really is going to matter when you're dealing with thirds. So being able to recognize, and that's why they even put the decimal form of 1/3 in this like 33 and 1/3, because once again, it's just telling us that this 3 basically repeats out to infinity and never, So yeah, so it only works with 1/3 or 2/3 is the only place I've seen these. And that's because, excuse me, and that's because this is the exact equivalent of this fraction. Okay. Otherwise, you're mostly going to be dealing with whole number percents. So it won't be as annoying. And so, of course, you can always use any of the fraction forms if you want, but you don't have to. Okay. So maybe we'll fill this out again maybe on next week, next Tuesday, when we're reviewing just to feel good about stuff. So yeah, so it's only these thirds, right? Our tenths, our fifths, our quarters are gonna be, whole numbers, fortunately. Okay. It's only the thirds that are funky.
Basically, like a measuring tape.
Mm-hmm. Yep, it goes in, right? You don't measure in thirds of inches usually. It's usually quarters, halves, sixteenths, eighths. Yep, exactly. And it's just because thirds are funky. I agree, Ryan. That's why we're here together. There's strength in unity. But yes. All right. Good job on those problems. I'm glad everyone's feeling pretty good about. Sorry, if I can just actually find the freaking page. I'm glad everyone's feeling good about expressions. So definitely be ready to see these style of questions, okay? And so if it says like which expression and you begin to look down at the answer choices, hopefully you can recognize what you guys were already saying. This is like what I'm going to put into my calculator to get my answer. And so basically they're saying, how do you set up the numbers and the operations, right? Are we dividing or are we multiplying in our problems? Okay. All right, let's jump to the next page. So this is page 53, I believe. And go ahead and we've got 5 minutes. Oh, never mind. Well, we might not. Let's just look at number 9 again and see how you guys do on another expression problem, okay? This one's percent change, so it's going to be a little bit, it's going to not be a little bit different. It's going to be different. Okay. I hope so too. We'll give everyone another minute or so as well, okay? Do you want to private message me your answer to see if you're right? You're just gonna do on sale price over original price times 100? But we need to figure out the percent change. So remember, for percent change, the top of our value should be, how would we figure out the amount of change between the original price and the sale price? Yeah. And I would say, yeah, for these problems, it's a little tricky. There's a lot that you have to, once again, kind of pay attention to, eliminate. So if you look here, B and D, we're subtracting, C and E, we're adding, and then what goes on the bottom there too, right? Yes, you can change. D is in donut. Good job. Good. It looks like people are getting answer D. Very good.
D.
Mm-hmm. And so to calculate our, right, percent decrease, we need to find the amount of change, which means we take our original price, subtract the sale price. So that's what we see up at the top of our fraction here. Then we know what goes on the bottom, right? Our original amount, not the sale price. So, right, B and C have the wrong denominator because that's not our original price. And then as you can see, all of the answers have this times 100%. So you could mostly ignore that, right? And really hopefully just look at the, okay, what do? I need to be subtracting on top. And then what number goes on bottom? My original. So yes, answer D. Any questions about this problem? Okay. Good work today, everyone. So I think like we were thinking, we'll probably just do review next week, which makes sense. So we'll go back and review unit 1, and we'll come back and review unit 2 next week. And try and come up with something fun. That's a lot of pressure though, I shouldn't promise. And of course, any problems that we're not working on in the book, in class, you can do on your own outside of class. And then I also put in additional practice here as well. So lots of opportunities to practice if you have the time and interest. Okay. If not, we'll review these 2 units next week. We'll have a week break and then we'll come back and start unit 3. Okay.
Okay.
All right. Thank you guys. Have a great rest of your day. And yeah, we'll see you on Monday or Tuesday next week.
Question. Did I get the attendance for today?
Let me put it in the chat for you. Everyone else hopefully was able to sign in. Okay. All right, sounds good.